Hello friends, today we are guiding you to prepare interview questions on machine learning. In comments you can share the topic of your interest. Our team will prepare the video for you. Before continue to our session, we request you to join our channel for all the latest updates. Our team of technical and subject matter experts are working hard to create valuable content just for you. So please make sure to hit the subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. What is K-nearest neighbors, KNN, and when should you use it? K-nearest neighbors, KNN, is a simple and intuitive machine learning algorithm used for both classification and regression tasks. It is a non-parametric algorithm, meaning it makes no assumptions about the underlying data distribution. Instead, it makes predictions based on the proximity of data points in the feature space. In classification, KNN assigns a class to a data point by looking at the K closest training samples, neighbors, and selecting the most frequent class among them. For regression, the output is the average of the values of the K closest neighbors. The algorithm works by computing the distance between the test data point and all points in the training set, using metrics such as Euclidean distance or Manhattan distance. The value of K, which represents the number of neighbors considered, is a key hyperparameter that influences the model's performance. A small k might lead to high variance, overfitting, while a large K might lead to high bias, underfitting. KNN is particularly effective when the decision boundary is highly nonlinear and when there is a high degree of local patterns in the data. However, it can be computationally expensive, especially with large datasets, as it requires calculating distances for every test point. In summary, KNN is useful for problems with complex, nonlinear decision boundaries and works well for smaller datasets with meaningful distance metrics. What is the naive Bayes algorithm, and what are its assumptions? The naive Bayes algorithm is a family of probabilistic classifiers based on Bayes' theorem, which is used for both classification and prediction tasks. It is called naive because it assumes that all features are independent of each other, which is often not the case in real-world data. Despite this simplifying assumption, naive Bayes often performs surprisingly well, especially with high-dimensional data like text classification. The algorithm works by calculating the probability of each class given the input features using Bayes' theorem. P class, features, equals P features, class, P features. It then assigns the class with the highest probability to the given data point. The key assumptions of naive Bayes are feature independence. The most crucial assumption is that the features are independent given the class label. This means that knowing the value of one feature does not provide any information about another feature. Conditional probability. It assumes that the probability of each feature given the class follows a specific distribution, often Gaussian, for continuous features, or multinomial, for discrete features like word counts in text. Despite the naive assumption, naive Bayes is computationally efficient, easy to implement, and works well for tasks like spam detection and text classification, particularly when the features are relatively independent. What is support vector machine, SVM, and how does it work? A support vector machine, SVM, is a powerful supervised machine learning algorithm primarily used for classification tasks, though it can also be used for regression. SVM aims to find the optimal hyperplane that best separates data into different classes in a high-dimensional space. This hyperplane maximizes the margin between the classes, which is the distance between the hyperplane and the closest data points from either class, known as support vectors. In simple terms, SVM tries to draw a boundary between classes in such a way that the margin between the two classes is as wide as possible. The points that are closest to the hyperplane and influence its position are called support vectors. These support vectors are crucial for determining the optimal hyperplane, and only a small fraction of the data points are needed for this decision. For nonlinearly separable data, SVM uses the kernel trick, which transforms the data into a higher dimensional space where a linear separation is possible. Common kernels include linear, polynomial, and RBF, radial basis function. SVM is effective for high-dimensional spaces and is known for its robustness in classification tasks, particularly when the classes are well separated. However, it can be computationally intensive, especially with large datasets. In summary, SVM is a powerful algorithm that finds the optimal hyperplane to classify data, and its ability to handle nonlinear separations via kernels makes it highly versatile. How do kernel functions work in SVM? N-support vector machine, SVM, kernel functions play a crucial role in enabling the algorithm to handle nonlinearly separable data. While SVM is naturally designed to find a hyperplane that separates data points linearly, many real-world datasets cannot be separated by a straight line in their original feature space. This is where kernels come into play. A kernel function transforms the input data into a higher dimensional space, where it becomes easier to find a linear separation between the classes. Essentially, kernels allow SVM to compute the dot product of the data points in this higher dimensional space without explicitly calculating the transformation, which would otherwise be computationally expensive. This approach is known as the kernel trick. There are different types of kernel functions used in SVM, each suitable for different data structures. Linear kernel. This is used when data is already linearly separable. It doesn't transform the data and simply computes the dot product in the original space. Polynomial kernel. This allows for the separation of data using polynomial decision boundaries. Radial basis function, RBF, kernel. This is the most commonly used kernel, effective in capturing complex relationships by mapping data into an infinite dimensional space. In summary, kernel functions in SVM enable the algorithm to solve nonlinear problems by implicitly mapping data to higher dimensional spaces, allowing for more accurate and flexible classification boundaries. What is the difference between bagging and boosting? Bagging and boosting are both ensemble learning techniques used to improve the performance of machine learning models by combining multiple weaker models, usually decision trees, to create a stronger model. However, they differ in their approach and underlying principles. Bagging, bootstrap aggregating, works by training multiple models independently on different random subsets of the training data, which are generated through bootstrapping, sampling with replacement. Each model is trained on a different sample of the data, and their predictions are aggregated by averaging, for regression, or voting, for classification. The goal of bagging is to reduce variance and improve stability by combining predictions from multiple models. Random forest is a popular example of a bagging technique. Boosting, on the other hand, trains models sequentially, where each new model is trained to correct the errors made by the previous one. Boosting assigns higher weights to misclassified data points, forcing the next model to focus more on these harder to classify examples. The final prediction is made by combining the weighted predictions of all the models. Boosting reduces both bias and variance and often results in a stronger model compared to bagging. Examples of boosting algorithms include DataBoost, gradient boosting, and XGBoost. In summary, bagging focuses on reducing variance by training models in parallel, while boosting reduces both bias and variance by training models sequentially and correcting errors from previous models. Thanks for watching the video till the end. If you liked the video and haven't subscribed yet, please hit subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. In comments you can share the topic of your interest. Our team will prepare the video for you.